Today, I'm explaining the relationship between zeros and coefficient of a polynomial. Zeros of a polynomial is the point where the polynomial becomes zero. Let us consider the linear polynomial. The general form of a linear polynomial is ax plus b. For this polynomial, we have to find is there any relationship between zeros and coefficient of a polynomial. So we can write this polynomial equal to 0. Ax plus b equal to 0. Why? Because we are going to find the zeros of this polynomial. Zeros of the polynomial means the point where the polynomial becomes 0. So this polynomial equal to 0. Now we can find the point. Now x equal minus b. The x equal to minus b by a. See here this minus b, the minus constant term by a. A is the coefficient of x. Now we can write x equal minus constant term by coefficient of x. This is the relation between zeros and coefficient of a linear polynomial. This we already discussed in previous video. If you have any doubt, please go through that. Now we'll go to quadratic polynomial. We can check is there any relation between the zeros and coefficients with quadratic polynomial. So the general form of a quadratic polynomial is x square plus bx plus c. To find the relation, first we will check with an example. See the example. The p of x equal to x square plus 8x plus 6. Now we can write p of x equal 0. So 2x square plus 8x plus 6 equal to 0. Now we have to find the factors of this polynomial. From the factors, we can find the zeros. So how to find the factors of this polynomial? We can use the factorization method by splitting the middle term. See here, this 8x is the middle term. Now we can split this 8x into 6x plus 2x. Now I wrote 2x square plus 6x plus 2x plus 6 equal to 0. See here, how we can select this number 6, 2. This 8 we can write as 4 plus 2, 4 plus 4 or 7 plus 1. How we can understand this 6 plus 2 is the correct? How? This based on one principle. See this 6x plus 2. By adding these 6 and 2, we will get the middle term. By multiplying, we should get that constant term. See here it is constant. 2x square plus 8x plus 6. 6 is the constant. Here it is a is third. A is 2. So we are multiplying this 2 and 6. Then 12. So this 12 we are considering as the constant. So 6 into 2 is 12. Now we can write 2x square plus 6x plus 2x plus 6 equal to 0. From the first two terms, we can take 2x outside. 2x is the common factor. So 2x is out, then x plus 3 plus. From these two, 2 is the common factor. So 2 into x plus 3 equal to 0. See this 2x and 2. 2 is the common factor. So 2 outside x plus 1 into x plus 3 equal to 0. Now x plus 1 equal to 0 and x plus 3 equal to 0. So x equal to minus 1 or x equal to minus 3. The zeros of x square plus 5x plus 6 is minus 1 and minus 3. We got the zeros. Now we have to check is there any relation between the zeros and coefficient of a quadratic polynomial. How we will check that? We can find the sum of these zeros. How it will be? See this, sum of the zeros equal minus 1 plus minus 3. See, minus 1 and minus 3 are the zeros. So, sum of the zeros minus 1 plus minus 3. So, it is minus 4. So, minus 4 we can write as minus 8 by 2. See here the minus 8 minus coefficient of x by 2. 2 is the coefficient of x square. So, we can write as minus coefficient of x by coefficient of x square. Now we can write sum of the zeros equal minus coefficient of x by coefficient of x square. This is one relation. The another one, we can find the product. The product of the zeros equal minus 1 into minus 3. So it is 3. This 3 we can write as 6 by 2. See here 6 is the constant term by 2. 2 is the coefficient of x square. So we can write as product of zeros equal constant term by coefficient of x square. See, these two are the relationship between the zeros and coefficient of a quadratic polynomial. In general, we can consider the polynomial p of x equal ax square plus bx plus c. This is the general form of a polynomial. And alpha and beta are the zeros. Now we can write the factors of this polynomial as x minus alpha and x minus beta. The zeros of the polynomial is alpha and beta. So the factors are x minus alpha and x minus beta. Now we can write this polynomial ax square plus bx plus c equal product of these factors. So k into x minus alpha into x minus beta. This k is any constant. Now expand this x minus alpha into x minus beta. How to expand? First multiply this x into x. These two terms. So x square minus alpha into x minus alpha x. Now x into minus beta, minus beta x plus minus alpha minus beta is alpha beta. Minus into minus is plus. So we got here it is plus. By rearranging, we will get k into x square minus alpha plus beta x plus alpha beta. Now we can write x square plus bx plus c equal kx square minus k alpha beta x plus k alpha beta. Now we can compare the coefficient of x square, coefficient of x and constant term. See here, first the coefficient of x square is a. See here, the coefficient of x square is k. So we can write a equal to k. The next coefficient of x is b. Here coefficient of x equal minus k into alpha plus beta. So b equal minus k into alpha plus beta. Now the constant term here it is c. Here it is k alpha beta. So c equal to k alpha beta. Now we can write, see here, this alpha beta equal minus b by k. See here minus b by k. This k equal to a. See here a equal to k. So instead of this k we can write a. So it is minus b by a. The next alpha beta equal to c by k. Instead of this k we can write as c by a. This is the relationship between the zeros and coefficients of a quadratic polynomial. Now we'll go to the exercise. Exercise 2.2. The first question is, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and coefficients. How to find the relationship between zeros and coefficient that we already discussed. Based on this principle, we can find. So the first one is x square minus 2x minus 8. This equal to 0. How we should find the factors? by splitting the middle term. See, x square plus 2x minus 4x minus 8 equal to 0. See here, minus 2x is the middle term. This minus 2x I wrote 2x minus 4x. See, plus 2 minus 4 equal minus 2. This 2 into minus 4 is minus 8. So in first two term, x is the common factor. So x into x plus 2 minus. See here minus 4 is the common factor. So minus 4 into x minus 8. So minus 4 is the common. So it is plus 2 equal to 0. Now we can write x minus 4 into x plus 2 equal to 0. The factors are x minus 4 and x plus 2. So we got that x equal to 4 and x equal to minus 2. The zeros of x square minus 2x minus 8 are 4 and minus 2. Now the sum of the zeros minus 2 plus 4 equal to 2 is the coefficient of x by coefficient of x square. See here 2 minus of 2 is minus 2. So minus coefficient of x here, x here. So coefficient of x is minus 2. Next, the coefficient of x square. See here, x square is 1. So it is minus coefficient of x by coefficient of x square. The product of zeros equal minus 2 into 4 is minus 8. See here, minus 8. The constant term by coefficient of x square. The constant term is minus 8 by coefficient of x square is 1. So, constant term by coefficient of x square. The next one, 4s square minus 4s plus 1 equal to 0. To simplify this equation, I divide this equation by 4. So we got that s square minus s plus 1 by 4 equal to 0. Now we can split the middle term. So s square minus 1 by 2s minus 1 by 2s plus 1 by 4 equal to 0. See here 1 by 2 and 1 by 2 minus 1 by 2 minus 1 by 2. By adding we will get the middle term. By multiplying we will get the constant term. So the first two terms s is the common factor. So s into s minus 1 by 2 minus, see here minus 1 by 2 is the common factor. So s minus 1 by 2 equal to 0. So s minus 1 by 2 into s minus 1 by 2 equal to 0. So s equal to 1 by 2 is the zeros of 4s square minus 4s plus 1 or s square minus s plus 1 by 4. Now the sum of the zeros 1 by 2 plus 1 by 2 equal to 1. See here the coefficient of s is 1. So minus coefficient of s by coefficient of s square. The product of zeros equal 1 by 2 into 1 by 2 equal 1 by 4. See the constant term 1 by 4 by coefficient of s square is 1. So it is 1 by 4. Now the next question is 4u square plus 8u equal to 0. From these two, we can take 4u as the common. So 4u into u plus 2 equal to 0. So u equal to 0 for u equal to 0 or u plus 2 equal to 0. So u equal to 0 or u equal to minus 2. So the zeros of 4u square plus 8u are 0 and 1 by 2. Now the sum of the zeros equal 0 plus 1 by 2 equal minus 1 by 2. So this minus 1 by 2 we can write as minus 8 by 4. See here minus the coefficient of u is 8 by coefficient of u square is 4. So minus 8 by 4. The product of zeros equal 0 into 1 by minus 2 equal 0. See here the constant term is 0. So the product of zeros is 0. The next one, t square minus 15. This is of the form a square minus b square. This we can write as a plus b into a minus b. So the t square minus 15 equal to 0. So t plus root 15 into t minus root 15 equal to 0. Now t equal root 15 or t equal to minus root 15. The sum of the zeros equal root 15 plus minus root 15. This is equal to 0. One is positive, one is negative. So it is 0. See here, the coefficient of t. T term is not there. So it is 0. So the sum of zeros is zeros. The product of the zeros equal root 15 into minus root 15. So root 15 into root 15 is 15. So here it is minus. So minus 15. So minus 15. See here the constant term by coefficient of t square. So the next question is, find the quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. See here, they are giving the sum and product of the zeros. From this, we should find the quadratic polynomial. How to find? We'll see that. The first one is 1 by 4 and minus 1. So let us consider the general form of a quadratic polynomial ax square plus bx plus c, and the zeros are alpha and beta. So we know the relation, the sum and product. The sum of the zeros alpha plus beta equal minus b by a. See, the first one is the sum. See here, the sum and product. So the first one is sum, the second one is the product. So the sum is 1 by 4. It is minus b by a. So from this, minus b equal, see the minus 1, and a equal 4. The next one is alpha beta, the product, equal minus 1. See, the second one is the product. Product is minus 1. This we can write as c by a. So this we can minus 1 we can write as minus 4 by 4. See here, this is a. A is here is 4. So here also 4. So we can write as minus 4 by 4. From these two, if a equal to 4, see here, a equal to b by a and c by a. From this 4 is a. Then b equal, see here, b equal to minus 1 and c equal minus 4. Now we can write the polynomial. See here, instead of this a we can give 4, this b we can give minus 1, and this c we can give 4. Now the polynomial is 4x square minus x minus 4. The next one, root 2 and 1 by 3. Root 2 is the sum and 1 by 3 is the product. So let us consider the general form of a polynomial ax square plus bx plus c, and zeros are alpha and beta. So the sum of the zeros alpha plus beta equal the first one root 2. The sum is minus b by a. So this root 2 we can write as 3 root 2 by 3. How? See here, the product is c by a. The a is 3. So in this also a is 3. So we are multiply and divide by 3. The next alpha beta, the product equal 1 by 3. See here, it is c by a is 3. From this, if a equal to 3, see here, a equal to 3, a equal to 3, a equal to 3, then b equal minus 3 root 2 and c equal 1. Now we can write the quadratic polynomial. Instead of this a, we can give 3, b equal minus 3 root 2 and c equal 1. Therefore, the quadratic polynomial is 3x square minus 3 root 2 plus 1. The next problem is 0 root 5. Let us consider the quadratic polynomial ax square plus bx plus c and the zeros alpha and beta. Now the sum alpha plus beta equals 0 by 1 is minus b by a. See here this 0 we can write as 0 by 1. And alpha beta the product is c by a. See here root 5 by 1. From these two a is 1. If a equal to 1 then b equal, see here b equal 0 and c equal root 5. So therefore we can write the quadratic polynomial by substituting a, b and c in the general form. So the quadratic polynomial is x square plus root 5. See here a is 1. Then b term is 0. So it is not there. Then the c is root 5. So the quadratic polynomial is x square plus root 5.